Assalamualaikum ji. My name is Mohammed Zamil Faisal. So we've been assigned a task by Sir Umar Farooq to make a video of the project that we made this semester in instrument and measurements class. Okay, so first up tell you about the names of the group members that are included. So we were only two members, and as Sir had the policy that if you are two members in a group, then you have to just use four sensors in your project. So we've just done just that. A little bit intro of what we've done will be given after this. First, I'd like to explain who are me and my project mate is. So my project mate is Muhammad Abu Bakr. He was the creative behind this project, and I was mainly the technical and creativity head in this project. So next step after the introduction page is that we have the content table in which we have the objective, the introduction, the equipments required, the sensors, the microcontroller, the board and the PCB, and the connections and the software, as well as the working principle and schematic of sensors. The sensors that we used in this project, in our project, were with the water level sensor, the current sensor. You can see the number that is assigned to the current sensor, which means that it is a specific type of current sensor that we have used. There's also the temperature sensor as well as the ultrasonic sensor. We also have the light sensor, the U sensor encoder, and the voltage sensor. So the voltage sensor, the encoder, and the current sensor were asked us to put in the project by Sir as they were made compulsory. So we also have the Proteus diagram, the block diagram, and the PCB. We also have the hardware implementation and the conclusion in our content table. Next up, next up is the name of the team and their group members, as well as our roles of what we've done. So I was the project manager as well as the technical manager in this project. So we've both written half of the reports each, and we've interfaced half of the circuit. So basically what I'm trying to say is that we've both done half the work in our project, so nobody feels like he's done more work or less work than the other. Okay, so the initial feasibility in our project was basically it is the automation car system, or the working principle I can say is that it is the automatic system in a car which performs several functions. All these functions, as you know, would provide a different and automatic experience to the user. So in the newer cars that are now applicable or available in the market, you have these functions, but they're in those cars that are relatively expensive than the ones which we use in our normal day use. So it was important to create something as a project that would benefit others, as well as to have an idea that would help others, not just the rich class, but also all classes of people would benefit from that project. So the comparison with other similar products. So yeah, we have the comparison with the car systems in bikes or small size mobile robots. How is that the comparison? See, the main purpose or the main project that we made was the car systems. Was the system in cars, like how we can make it automatic for someone. For example, disabled people or normal they use. How can we make something automatic? Because that's where the market is going towards nowadays. It's going to more towards the automatic fields. So that's what our main goal was. So comparison, as for the comparison with other similar products, you can say that in small size mobile robots, they use several functions like turning on something or cooling something or measuring the temperature of something. These little robot toys or something, they use these functions. So we've made them like that to accomplish such tasks. But the problem we faced was that all of these were not available in a single system. So how do we use those in a single system? So that's what our main project was about. The team roles in our project was that we both interface half of the sensors, as well as we made different reports on that. So we had to change that with time as different requirements were required by our teacher. So yeah, that's are the team roles. As for the objective, we had an intelligent transportation system by using different sensors that revolve around the same application. So the main purpose is to collect data and display them differently so that a proper system would be established in a car. The introduction of our system would be that transportation systems have become a fundamental base for economic growth of all nations. Nevertheless, many cities around the first face problems such as in which they do not have the expenses or they do not have the limited amount to create something like these in which a system do not have uh, things like these delays, traffic jams, higher fuel prices, increase of CO2 emission, accident emergencies, and degradation of quality of life in modern society. So these are the problems that were faced by people in our projects. So that's why we decided to create something that would help and benefit others in our project. Communication technology, ICT in areas such as hardware advances in information and communication technology, ICT were both useful in hardware as well as in different societies or different environments that so the main purpose that our goal or main purpose that we of our project was that we had to create a system that would not just perform one or two functions, it would perform a collection of functions of more than five or six at the same time, like not at the same time but according to their needs. For example, if the temperature of the car would go below the room temperature, since the weather is not really good and it is really hot in some areas, so if that was the case then the AC in the car would automatically turn on. So these were the things that we were trying to accomplish. More about on that later when we discuss the sensors. This is a diagram we showed of how and what is in the car system. So you can see there's a rear camera, there are some AC sensors, the GPS, the global positioning system, which gives the location in longitudes and latitudes. The video cameras to reverse. These are some advancements that are made in the newer cars. The microphone, the radar sensor, the infrared sensor, the pressure sensor. These are some of the sensors that I'm naming. Mainly, we have used ultrasonic sensor here. So the equipment we've used is a water level sensor to determine the coolant in this case, the ultrasonic sensor, the current sensor, the temperature sensor, the light sensor, the encoder, and the voltage sensor. So the Arduino which we used was Arduino Uno, the laptop, and the serial cable were used to power and connect the Arduino with the laptop. So that's why the serial cable was used. As for the board and PCB, the Vero board copper sheet, and we use the solution of FCl3 and iron to etch the sticker. I'll discuss that when we move further in our project. The connection that we use was soldering kit to make the connections, as well as the copper cables. The software that we used in this project were Proteus and the Arduino IDE. So the working principle and the schematic of sensors that we use include the water level sensor. So basically the main purpose of water level sensor is to make the liquid level in a fixed container that is too high or too low or according to the needs of the user. So according to this method it can be divided into two types, contact type and non-contact type. The working principle of water level sensor would be that when put in a certain depth of a liquid, it would tell by using LEDs or something like that. It would basically display how much amount that there is in a container, or how much amount of fluid there is in a container to be respective. So that's the case that we use in this as a water level sensor we use in our project. How we have used it, so we have repurposed it as a coolant. That is the most common content is distilled water which is conductive, and since there are levels in it for conductance, so we have used it for that. And if there is an LED then we can use to indicate the range. So how did we use to indicate the range? So basically what we did was connect three LEDs such as green, red or yellow to just like a traffic light signal system, but we used the function as a bit different. So what we did was we took the LEDs and we connected it to the sensor and we gave the connection to the ground. So that when the container is full and the water sensor is dipped in, the green LED will be indicating that this container is full of liquid. As when it is too low, the red LED would be on, and when it is at moderate level of liquid, then the yellow light would turn on. So basically, this was the main purpose that we used as a water level sensor in our project. Um, the data sheet is given below, in which there are specific water level ranges, the extra cable, the optical sensor display, the pressure pipe options, and the severe flow options, and all of these things, conductance, sensitivity, and all of these things are given in the table, such as the conditions, the dynamic and static characteristics. All of these things are given. This is a diagram of the water level monitor, a general diagram. Next up is the ultrasonic sensor. So we use the ultrasonic sensor to measure the distance of a target, and we also used a buzzer with it to indicate how we would show that the sound or something was in the distance. So that's how we used it. Ultrasonic sensor usually has two main components. Those are the transmitter and the one which sends the signal, and the receiver which encounters the sound after it has traveled from the target. The ultrasonic sensor works by sending out a sound wave at a frequency above the range of human hearing. So, how we have used it? So, we have used it in such a way that it works like a proximity sensor, and we used a buzzer with it. So, that whenever a approaches a specific distance, the beep goes on. So, basically, this sensor can be used as safety and in traffic control conditions, I guess, because when a car is approaching too near, it might cause an accident, or in fast driving lanes or something like that, it would cause accidents and major injuries or even a death, uh, unfortunately. So we that's why we use this sensor to indicate that whenever a car would come too close in a distance to our car, it would go on or buzz on, so that it indicating that the car below or front is too close to apply, so that would apply play so that we would apply brakes, and then it would not result into an accident. A figure is given indicating the pins and also the front and back of the ultrasonic sensor. So the pin symbols indicate that one is VCC, the 5-volt power supply. The 2 is trigger pin, the trigger input pin. The echo is the receiver pin, which receives the signal, and 4 is ground, which is the power ground. Then below is given the uh, data sheet of the sensors, in which we have indicated the operating voltage, operating current, and things like that, max range and nearest range, etc. So next up is the temperature sensor. So we use this temperature sensor. Basically, temperature sensor is a device which is used to measure temperature. This can be air temperature, liquid temperature, or the temperature of solid matter. So how we used it? So we used it in such a sense that whenever the temperature, as I explained in the start of this video, whenever the temperature of the car would go below the room temperature or certain temperature that we have set, the AC would automatically turn on since it was too hot or because it was too hot. And whenever the temperature was moderate enough or cool enough, then the temperature AC would automatically turn off. So this was an important function that we created using this sensor, and it performed the specific task that we wanted to, and we achieved it successfully. So this was really important for us. And one important thing that using these sensors is that when we use these sensors, there are other sensors which are quite expensive. We could have also used them, but we use these sensors to make this system available for everyone in their cars, so that not that just the people who have a lot more money can use it. No, but everyone can use these kind of systems in their cars. And also it can be applied, so that it can be applied into the older versions of cars, making them more advanced. As for the working principle, sorry as for the working principle of this sensor, so it measures readings through electrical signals. Right, there is a transmitter which sends signals, and there is a receiver which sends signals, accept signals. So basically, we had a buzzer that would go off in a certain distance for the ultrasonic sensor. As in the case of temperature sensor, we connected it through the Arduino, and then we connected it to the laptop so that it would show the temperature on the temperature on the laptop. And basically what it would do was that two LEDs would be connected with the temperature sensor, one indicating that the temperature is too hot and the other indicating that the temperature is too cold. The light sensor, the conditions for the temperature sensor again are given, such as repeatability, accuracy, sensing element, operating range, and the power supply as well. Um, the pin sequence number are given, which one is power supply (VDD), two is data signal, three is null, and four is ground. The light sensor, the type of photo detector, also called photosensors that detect light. Different type of light sensors can be used to measure illuminance, respond to changes in the amount of light received, or convert light into electricity. So the working principle of it is that internal photoelectric effect is what it is based on. The light sensor is equipped with high precision photoelectric tubes, small flat plate in the photoelectric tube which is composed of needle type 2 tube. How we have used this, often the headlights automatically turn on in a car, in the newer cars. So this was a function that is available in the newer cars. So what happens in newer cars, the lights or headlights or the headlights basically automatically turn on when the intensity of light or when the light around the car is too low. So basically what we did is that we created this by using a light sensor in such a way that so that whenever the conditions would be too dark for someone to travel, these lights would automatically turn on. And when the light would go back to normal, in which a normal human being can see, then they would automatically turn off. So this was another important function that we used in our system by using a light sensor that will help not just us but also those who incorporate this in their cars in their cars. The current sensor is a fully integrated Hall-based effect current sensor with voltage isolation and integrated low resistance current conductor. Technical terms aside, it's simply put forth as a current sensor that uses this conductor to calculate and measure the amount of current applied. So how we have used it, there wasn't really a particular reason for it, but since if it was made compulsory, so we used a control. You have to use. So we use it to generate the voltage by determining the incoming current. The data sheet again is given here. It's also in the report. So the output voltage and the pins and all that is explained, such as the parameter and the isolation characteristics, as well as the selection guide. The voltage sensor. The voltage sensor basically is a wireless tool that can be attached to any number of asset machinery or equipment. They provide 24/7 monitoring, constantly watching for voltage data that could indicate a problem. How we have used it. So we basically designed this sensor by ourselves instead of buying it from somewhere else. This sensor actually converts the 12 voltage signal to an Arduino readable 5-volt signal using resistors and a voltage divider rule. Then this signal is fed basically through the Arduino through the analog port, and this uses the slope formula which then again converts the 5 volt to its original value. So it was really important. Here's the PCB schematic diagram of the voltage current sensor. The U sensor is up next. The optical encoder is a transducer commonly used for measuring rotational motion. It consists of a shaft connected to a circular disc containing one or more tracks of alternating transparent and opaque areas. A light source and an optical sensor are mounted on opposite sides of each track. So the Proteus simulation of this is also given. The PCB layout basically is given, in which we connected our encoder, the voltage sensor, the current sensor, uh, is given, and the potentiometer. So basically that part is made in a schematic diagram. The next up is the block diagram. Basically we've labeled all the sensors that are connected to the Arduino. We also connected the LEDs as well as the buzzer. So as you can see here, the voltage sensor is connected, the power supply is connected to the potentiometer, to the voltage sensor and the current sensor, and then their connections are given to the Arduino, as well as the optical sensor has some connections to A0 and other connections as well, like 5 volt, etc. So yeah, that the pink lines here represent the output, the blue lines represent the input, the black lines represent the ground, and the reddish lines represent the VCC that we have used in our program project. This is the general block diagram of our project, in which the encoder, voltage sensor, water level, and temperature sensor is used. This is the hardware implementation. This is the PCB layout, and this is the part that we have etched onto the wearable or connected onto the wearable. This includes the Arduino, the water level sensor, the current sensor, the the water level sensor, the temperature sensor, the light sensor, the Arduino, along with the ultrasonic sensor. So we use male headers for these to connect them into the pins. So we connect them into the wearable so that whenever we disassemble our project, we can remove them easily. Here the pin connections are given. These represent the analog pin, as well as the voltage and current values. Here are the LEDs given, in which, and the buzzer as well is given, which we have used with the ultrasonic sensor, the LEDs which we have used with the water level sensor, the encoder, the pins of encoder and all are given. Again, so these are the name of pins that we have used. The ultrasonic sensor is used in trigger pin is used as 9, and the Arduino, the echo pin is used as 10. The LEDs are used as 13 and 12. The buzzer is used as 2. Similarly for the temperature sensor, in which we have used as 7 as the LED, the digital pin as A0, and etc. So that's the compiled code that we have presented. And basically what we did was we took this code for each sensor which we had interfaced, and we compiled them into one. So basically what's written here are the pins which we have edited according to our needs, such as the analog pin in through the Arduino is A0, and the digital pin is 6. The LEDs are 13, and representing them are the colors, in which yellow is for 5. The trigger pin is 9, and the echo pin is 10, which we have used in the ultrasonic sensor. This temperature sensor is also included, which has these kind of pins as well. This is a complete code in which we have used loops as well, so that whenever the buzzer determines a high distance or a high beep, then it would be delayed for some seconds, and whenever it is low, it would be delayed for some second, depending upon the condition that we have used in there. For the coolant level, we have again used the LEDs, according to which it depends on the value of which the water level sensor is represented according to the color of LED turning on. For the conclusion, I can say that the commercial cost of cars in the automobile market is increasing day by day. It was necessary to create something like this. By using this, which is applicable in any car, irrelevant of whether it is, we can finally put the system to use, as it will provide a different approach to how a car is built, while also reducing the cost efficiently and making it available for all classes.